Hello viewers, in today's session we are going to discuss another important and conceptual problem from domain of functions. And in this session we are going to find out the domain of this function f of x, that is equal to 3 times sine inverse, and here we have the greatest integer of 1 plus 3x over 5. So this notation, that is the symbol, the square brackets, denotes the greatest integer function, right? So here we'll find out the domain of this function by using an important property of greatest integer function, right? And this problem is going to be an easy problem, and let us see how we can find out the domain of this function using an important property of greatest integer function. So let us start. So now let us take this expression which is inside the square brackets as p. So let us take p as 1 plus 3x over 5. So now we can write this function as 3 times sine inverse of greatest integer of p, right? Now see, here we have the inverse sine function. So we'll first apply the properties of sine inverse function, that is the domain of sine inverse function. And we know that from inverse trigonometric functions, if we have sine inverse theta, then the principal value branch of sine inverse theta lies in the interval that is minus pi by 2 to pi by 2, provided here this theta, it belongs to this interval that is minus 1 to 1. So we can now write theta is greater than or equal to minus 1 but less than or equal to 1, right? Okay, so now first we'll apply this concept. So here this theta may be taken as greatest integer of p. So here we have the first condition, that is the greatest integer of p should be greater than or equal to minus 1 but less than or equal to 1. So this is the first condition while finding out the domain of this function, right? Okay, so now from here we'll apply an important property of greatest integer function, and the property goes like this. If we have a real number, say p, and if we take the greatest integer of this p, and the greatest integer of p, it lies between minus n and n, where p belongs to the set of real numbers, and here this n, it belongs to some integer, right? So here when we have greatest integer of p greater than or equal to minus n and less than or equal to n, where p belongs to r and n belongs to z, then this p, that is this real number p, it should lie, that is it is greater than or equal to minus n but less than n plus 1, right? So here we'll make use of this property, right? And now if we take this inequality, and if we compare this inequality with this one, then the value of n is equal to 1, because here we have minus 1 and here we have 1, right? So n is equal to 1 and p is 1 plus 3x over 5. So now we have minus 1 less than or equal to greatest integer of 1 plus 3x over 5, and here we have 1. So now the value of p is 1 plus 3x over 5. So now substituting the value of p in this inequality, we have here for n1, and here we have 1 plus 3x over 5, and here we have n is 1, so we have 1 plus 1. So now we can also write this inequality as -1. Here we have 1 plus 3x over 5, and here we have 1 plus 1, 2. So let us now multiply throughout by 5. So we have here -5, then we have 1 plus 3x. Here 5 and 5 get cancelled, and here we have 10. So let us subtract 1. Throughout we have here 3x, and here we have 10 minus 1. So this is -6. Here we have 3x, and here we have 9. Now let us divide throughout by 3. So we have -2, and here we have simply x, and here we have 3, right? So from this inequality we can conclude that the valid values of x for which this function is defined, that is the domain of this function f of x, it should be given by this interval which is closed from the left and open from the right. So here 3 is not included, right? So we have -2, and here we have 3. So the domain of this function is given by this interval, that is from -2 to 3, where -2 is included and 3 is excluded.